Welcome to this presentation. My name is Marcus Olsson and I am a researcher at Norwegian Institute of Wood Technology. I will describe my work on energy management in Norwegian sawmills and present some lessons learned. This is a presentation originally held at the ECEEE conference in Gothenburg, Sweden in September 2020. I will start by introducing sawmills in Norway and put them in a global perspective. Then we will see why they implemented energy management and how they did it. I will show you some results from these ENMSs and give you some success factors in these cases. And ENMS will be used throughout the whole presentation, and it stands for Energy Management System. In a global perspective, the production is dominated by China and USA, and then Russia, Canada, Germany, and Sweden. And we find Norway in 31st place. The production in Norway is 2.7 million cubic meters of sawnwood, and it's dominated by 18 sawmills. The sawmills in Norway are relatively small in a global perspective. The production in Norway is dominated by Moelven with 12 sawmills and representing 40% of the production volume. Bergenholm is another big group, and then there are several smaller sawmills. The industry employs 3,600 people and the annual turnover is 1.1 billion euro. The energy mix in Norwegian sawmills mainly consists of biomass, electricity, and diesel. Diesel is used for internal transport, forklifts, and wheel loaders. The biomass is produced from byproducts in the production. The electricity used in kiln drying, saw house, and other processes, and biomass heat produced in the boiler is mainly used for kiln drying and other heating of buildings. So why did the sawmills introduce energy management? Well, the reason was not energy costs. They are only 5% of the total cost in Norwegian sawmills because of low electricity prices, biomass prices, and diesel prices. Instead, the reason why they implemented energy management was a national support program and requirements from authorities. The national support program made it possible for industry in Norway to apply for 100,000 euros to implement an energy management system. And the national requirements from authorities concern the boiler and the emissions from the boiler. In order to have a permit to run the boiler, they need an ENMS. So the reason was not that to save energy or save energy costs, it was because they had this support program and requirements from authorities. The benefits after implementing an energy management system were said to be reduced costs and reduced environmental footprint. And the reduced environmental footprint is important in the EPDs that are used. EPD stands for Environmental Product Declaration, and EPDs are used when you compare different products in the building. When you want to choose wood or some other material, you can compare them in this environmental way. The energy management system also meant that energy jobs got a higher status. The top management was engaged in energy efficiency, more people were engaged in energy efficiency, there was a clear division of responsibilities within the company. The ENMS created a joint framework, so we had a structured work with energy efficiency. It increased the fellowship within the company, and it increased process knowledge in general. It also meant that continual improvements were a natural part of the daily work. The ENMS concept that we have used in sawmills is called SawENMS, and that was developed in a European project called ECO in 2015. It puts the energy team in the center of the work. They are responsible for making investments to a certain degree and to lead the work with energy efficiency. They usually start with measuring the energy use in an energy review or mapping the energy use over the sawmill. And in general, these two steps, to have an energy team that is working and engaged and to visualize the energy use, is the two most important steps of this method. When you have these two parts in place, you can start by creating an energy efficiency culture. And you do that by have a transparent and shared action list or task list. You have routines for energy efficiency in the daily work. You set energy targets. You decide on an energy policy, and then you communicate this internally. All of these steps are described in the SawENMS handbook that's available freely on the EcoInflow website. So important introductory steps are: appoint an energy team. This gives a framework for energy management and it elucidates who is in charge. Start measuring the energy use and visualize it. Incorporate energy efficiency in the daily work. And here, if you introduce energy management as a consultant, it's very important to divide responsibilities between you as a consultant and what you expect from the sawmill personnel and what they can expect from you. You should use shared task lists immediately. They should clearly divide who is responsible for this action, when should it be finished. You should also include energy performance in weekly meetings, and in this way the top management shows that this is an important topic. By visualizing this energy use, you can monitor if you're fulfilling your targets. In this case, we have electricity use on the y-axis and the time on the x-axis. This particular sawmill wanted to have the week number on the x-axis so they can follow the performance during a year. We set a target with a dashed line. If the week has a higher energy use than the target, the bar is red, and the green bars shows when it's below the target. So you want as many green bars as possible. We also added a smoothed curve. So this is the running average from week 1. The current year is in black and the last year is in gray. And this could also be made for the last 52 weeks, so you can see the current state of the last year. But in this case, the sawmill wanted it from week 1. There are also some figures here for energy use per cubic meter of product. So on the y-axis, we have the electricity use again. On the x-axis are the week numbers. So to show you some more detail, I will zoom in. In the top, we have 2015, then we have 2016, 17, 18 in blue, 19 in gray, and the black one here shows this year. From the start, this part of the sawmill had an energy use of 66.8 kilowatt hours per cubic meters. That was in 2015. So each data point here represents the sum of energy use for the last 52 weeks divided by the production during these 52 weeks. In 2019, in the spring, the sawmill set a record. They used 53.5 kilowatt hours per cubic meters, and that's a decrease of 20%, and that's worth 90,000 euros per year. After the printing of this paper, they set a new record some 2-3 weeks ago that decreased the energy use by 1 more percent. Another way of showing the energy use is to compare it with the production. So in this case, it's well, the economy of scale says that a higher production volume will decrease the energy use per product unit. And that was really true also in the sawmill industry. So here we have the energy use on the y-axis and the weekly production volume on the x-axis. And you can clearly see that economy of scale is is working here as well. Increased production means reduced energy use per production unit. Now I will talk about other energy efficiency measures, and if you could call this a measure, but increased awareness alone resulted in 2 to 5% savings in the first year. So just by visualizing how much energy do we use, where is it used, and divide it in departments, it created an energy efficiency culture with many small measures. So we couldn't see any large investments during this first year, but just by showing or visualizing the energy use, 2 to 5% was saved. If you have old pipings in the ground, you should definitely replace them. In this case, the sawmill had been talking about this for 5 to 10 years, but it never happened. But when they had an ENMS, it really happened. And as a side story, the sawmill in this case, they didn't have to remove snow in the winter because the insulation was so bad in the old pipes. So after replacing the pipes, they had to remove snow. So that was a downside of this measure. So as I said before, many small measures have a payback period of below 1 year. For example, there was this image here to the right, shows a pipe with over 100 degrees Celsius. By bypassing this, the plumber could bypass it in 1 to 2 hours work. They could save a lot of energy. So small easy measures is often possible in many cases. The compressed air system is a problem of its own usually. They have a lot of leakages. In this case, they had a zone division, but yet they could see in the graphs that it didn't work. So one of the valves didn't work. When it was closed, it was still open. Another sawmill had problems with the automatic on-off during nights and evenings between production. It didn't work. You could see that in the graphs. And there are also some more technical measures like optimizing kiln drying programs. And then you have to know the process more. So the success factors is in this case to create a motivated energy team. They should have the appropriate amount of resources. They should have the freedom to take action. We should avoid adding bureaucracy here. So the team should be working on their own mostly. The top management should be inquiring. They should ask for results in a good way. Include energy management in weekly meetings, for example. In this way, you can have a discussion on what happens and what the results are. You should learn from others. Don't be afraid of asking other sawmills what they have done. You should use strategic partners for some parts of the work, like visualization could be best done with a consultant maybe. Machine suppliers, they are happy to help. They want to sell machines to you, and before they have done that, they can do a lot of work by implementing the best kind of machine, especially in this energy purpose. A machine, you should not only look at the investment, but the maintenance costs and the energy use is often much more important than the investment itself. And by doing all of these steps, you should create an energy efficiency culture. The energy efficiency work should be a part of the daily operations. It should not be an additional work. that you do on the side. It should be a natural part of your daily work. And you should aim for continuous improvements. It's not finished in the first year or the second year. It's an ongoing work that never stops. Final advice is to keep it simple. Don't overcomplicate or think too much before you start. As soon as you start measuring, you will learn something. And begin where the costs are the greatest. Thank you for listening to this presentation. Do not hesitate contacting me should you have further questions.